ceiling fan with a light kit satisfies the code requirement for illumination in a bedroom or other habitable space. While a ceiling fan with a light kit meets code, it may not be the most desirable or aesthetically pleasing option. The best approach is to balance code compliance with the owner's aesthetic preferences. Firstly, discuss the concerns about the aesthetics of multiple switches for fans and suggest alternative lighting solutions with the builder. Inquire about the owner's preferences and if they have any specific requirements for lighting in the bedrooms and lanais. Secondly, bid a competitive price for the code-compliant option, a ceiling fan with a light kit, ensuring a reasonable profit margin. If the owner requests additional lighting fixtures, bid those separately and include the cost of installation and materials. Thirdly, consider alternative lighting solutions such as recess lighting. Install recessed light in the ceiling to provide general illumination. This can be a more aesthetically pleasing and functional option compared to multiple switches for fans. Fourthly, consider wall sconces. Install wall-mounted sconces to add ambient lighting and create a more inviting ambience. Fifthly, consider pendant lights. Suspend pendant lights from the ceiling to provide task lighting or decorative accents. Sixthly, consider coach lights. Install coach lights on the lanais to provide both illumination and a decorative touch. Finally, clearly communicate the recommendations and any additional costs to the builder for any lighting solutions that go beyond the code-compliant option. Be prepared to explain the benefits of these alternative solutions and how they can enhance the overall aesthetics and value of the home. When planning electrical installations, several key factors must be considered to ensure safety, compliance, and functionality. Firstly, the National Electrical Code, or NEC, is a comprehensive set of standards that governs electrical installations in the United States. It's crucial to adhere to the NEC to ensure the safety of people and property. The NEC is updated every 3 years, so staying current with the latest edition is essential for all electrical professionals. Secondly, conductor sizing is a critical aspect of electrical installations. The correct conductor size must be selected to safely carry the intended load. The NEC provides tables, such as Table 310.15b16, that specify the allowable ampacities of conductors based on their insulation type, ambient temperature, and the number of conductors in a raceway or cable. Using conductors that are too small can lead to overheating, insulation damage, and even fire. Thirdly, overcurrent protection is another vital safety measure. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that can result from overloads or short circuits. The NEC specifies the maximum overcurrent protection for various types of conductors and equipment. For example, a 14 American wire gauge copper conductor with type THHN insulation is typically protected by a 15 amp circuit breaker. Fourthly, grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, allowing the overcurrent protective device to trip and de-energize the circuit. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors. Fifthly, wiring methods refer to the types of cables and raceways used to install electrical conductors. Common wiring methods include non-metallic sheath cable NM cable, also known as Romex, electrical metallic tubing ENT, and rigid metal conduit RMC. The NEC specifies the permitted uses for each wiring method. For example, NM cable is typically used in residential wiring, while ENT and RMC are often used in commercial and industrial applications. Sixthly, box fill calculations are necessary to ensure that electrical boxes are not overcrowded with conductors and devices. Overcrowded boxes can lead to overheating and damage to the conductors and devices. The NEC provides rules for calculating the maximum number of conductors and devices that can be installed in a box based on its size. Seventhly, voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of electrical systems. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Eighthly, arc fault circuit interrupters, or RSIs, are designed to protect against arc faults, which are dangerous electrical arcs that can cause fires. The NEC requires RSIs in many areas of the home, including bedrooms, living rooms, and dining rooms. RSIs can detect arc faults and quickly de-energize the circuit, preventing a fire. Ninthly, ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which occur when current leaks to ground. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs can detect ground faults and quickly de-energize the circuit, preventing electric shock. Tenthly, lighting and appliance branch circuit calculations are necessary to determine the required capacity of branch circuits that supply lighting and appliances. The NEC provides rules for calculating the load for lighting, receptacles, and appliances. For example, a general lighting load is typically calculated at 3 volt amps per square foot for residential occupancies. When dealing with specific appliances like air conditioners, it's crucial to refer to the NEC for proper wiring and circuit breaker sizing. For instance, Section 440.22 of the NEC provides guidance on the sizing of conductors for air conditioning and refrigeration equipment. It states that the branch circuit conductor supplying a hermetic refrigerant motor compressor shall have an ampacity not less than 125% of the rated load current or branch circuit selection current, whichever is greater. This ensures that the conductors can handle the continuous load of the air conditioner without overheating. Similarly, Section 440.22b covers the sizing of overcurrent protection for air conditioning equipment. It states that the branch circuit, short circuit, and ground fault protective device shall be capable of carrying the starting current of the motor compressor. The NEC provides tables and guidelines for determining the appropriate size of the overcurrent protection device based on the type of motor compressor and the characteristics of the circuit. Another crucial consideration is the location of electrical equipment in relation to wet or damp locations. Section 110.11 of the NEC requires that electrical equipment be suitable for the environment in which it is installed. In wet locations, such as outdoors or in bathrooms, equipment must be listed for wet locations or protected from the weather. In damp locations, such as basements or garages, equipment must be listed for damp locations or protected from moisture. Additionally, the NEC addresses the installation of electrical equipment in hazardous locations, such as areas where flammable gases or vapors are present. Article 500 of the NEC provides detailed requirements for electrical equipment installed in hazardous locations, including the type of equipment that can be used and the wiring methods that are permitted. Furthermore, the NEC covers the installation of renewable energy systems, such as solar photovoltaic or PV systems. Article 690 of the NEC provides requirements for the installation of PV systems, including the sizing of conductors, overcurrent protection, and grounding. The NEC also addresses the interconnection of PV systems with the utility grid. In addition to the NEC, there may be local codes and regulations that govern electrical installations. It is important to check with the local authority having jurisdiction or OJ to ensure that all electrical installations comply with the applicable codes and regulations. The AHJ is typically a local government agency or a state agency that is responsible for enforcing electrical codes. They may have additional requirements beyond the NEC, so it is important to be aware of them. Proper planning and execution are essential for safe and compliant electrical installations. This includes carefully reviewing the plans and specifications, selecting the appropriate materials and equipment, and following the NEC and local codes. It also includes proper documentation of the installation, including wiring diagrams and test results. This documentation can be helpful for future maintenance and troubleshooting. For instance, when installing a subpole in a residential setting, several considerations must be taken into account to ensure safety and compliance with the National Electrical Code. Firstly, the ampacity of the feeder conductors supplying the subpanel must be sufficient to carry the expected load. This is typically calculated based on the square footage of the area served by the subpanel and the types of appliances and equipment that will be connected. The NEC provides guidelines for calculating the load, and it's essential to ensure that the feeder conductors are adequately sized to prevent overheating. Secondly, the subpanel must be properly grounded. This involves connecting the subpanel to the main grounding electrode system of the building. The grounding conductor must be sized according to the NEC, and it must be securely connected to the subpanel and the grounding electrode. Proper grounding is crucial for preventing electric shock and ensuring the safe operation of electrical equipment. Thirdly, the subpanel must be equipped with overcurrent protection devices, such as circuit breakers, to protect the branch circuits from overloads and short circuits. The circuit breakers must be sized according to the ampacity of the branch circuits, and they must be properly labeled to indicate the circuits they protect. It's also important to ensure that the subpanel has sufficient capacity to accommodate the expected number of branch circuits. Fourthly, the subpanel must be installed in a suitable location. It should be readily accessible for maintenance and repairs, and it should be protected from physical damage. The NEC also specifies minimum clearances around electrical equipment to ensure safe access for personnel. Fifthly, all wiring connections in the subpanel must be made securely and properly. This includes tightening all screws and terminals to the correct torque. Loose connections can cause overheating and arcing, which can lead to electrical fires. It's also important to ensure that the wiring is neatly organized and properly supported. Sixthly, the subpanel must be properly labeled to indicate its purpose and the circuits it serves. This helps to prevent confusion and makes it easier to troubleshoot electrical problems. The labels should be clear and easy to read, and they should be permanently affixed to the subpanel. Seventhly, a licensed electrician should inspect the installation of the subpanel to ensure that it complies with all applicable codes and regulations. The electrician will check the wiring connections, grounding, and overcurrent protection to ensure that they are properly installed. They will also perform tests to verify the safety and functionality of the subpanel. Eighthly, when installing electrical equipment outdoors, it's essential to consider the environmental conditions. Equipment that is exposed to the weather must be rated for outdoor use, and it must be protected from rain, snow, and ice. The NEC provides guidelines for the installation of outdoor electrical equipment, including the use of weatherproof enclosures and fittings. Ninthly, electrical installations in bathrooms and kitchens require special attention due to the presence of water. Ground fault circuit interrupters, or GFCIs, are required in these areas to protect against electric shock. The NEC specifies the locations where GFCIs are required, and it's important to follow these requirements to ensure safety. Tenthly, when working with electrical equipment, it's essential to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It also includes de-energizing circuits before working on them and verifying that they are de-energized using a voltage tester. Always follow lockout/tagout procedures to prevent accidental re-energization of circuits. Moreover, the NEC provides guidance on the installation of low-voltage lighting systems, such as those used for landscape lighting or accent lighting. Low-voltage lighting systems typically operate at 12 volts or 24 volts, which reduces the risk of electric shock. However, it's still important to follow the NEC requirements for wiring, grounding, and overcurrent protection to ensure safety. The NEC also addresses the installation of electrical equipment in agricultural buildings such as barns and poultry houses. These buildings often have unique electrical requirements due to the presence of dust, moisture, and corrosive materials. The NEC provides specific requirements for wiring methods, grounding, and bonding in agricultural buildings to ensure safety. Furthermore, the NEC covers the installation of emergency power systems such as generators and uninterruptible power supplies, or UPSs. Emergency power systems provide backup power in the event of a power outage. The NEC provides requirements for the sizing of generators, the installation of transfer switches, and the wiring of emergency circuits to ensure that the emergency power system operates safely and reliably. In addition to the technical requirements of the NEC, it's also important to consider the aesthetic aspects of electrical installations. This includes the placement of outlets, switches, and lighting fixtures to create a visually appealing and functional space. It also includes the selection of wiring devices and cover plates that complement the decor of the room. A well-designed electrical installation can enhance the value and enjoyment of a home or building. When working with older electrical systems, it's important to be aware of the potential hazards, such as asbestos-insulated wiring and knob and tube wiring. Asbestos-insulated wiring can release asbestos fibers into the air when disturbed, which can pose a health risk. Knob and tube wiring is an outdated wiring method that is not as safe as modern wiring methods. If you encounter these types of wiring, it's best to consult with a qualified electrician to determine the best course of action. Maintaining electrical systems is crucial for ensuring their safe and reliable operation. This includes regularly inspecting wiring, devices, and equipment for signs of damage or wear. It also includes testing ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, to ensure that they are functioning properly. Regular maintenance can help to prevent electrical problems and extend the life of electrical systems.